Okay, so let's take a look at another electromagnetics question. We've got two current-carrying wires parallel to each other. Is it possible for the forces produced to point in the same direction? Okay, so let's draw two wires. We have one wire here, and then we have one wire here. And these wires are essentially parallel to one another. Now let's think about the orientation of the currents. So let's have current in the first one going up. Let's have the current in the second one going up. So I1 and I2 currents are both going up. Using your right hand rule, you point your thumb in the direction of the current, and then the direction in which your fingers wrap around, like so, this is going to be the direction of the magnetic field. So for both of these wires, the magnetic field is going to go around this way. If we looked at this from above, this would be counterclockwise. So this one also goes around this way. This one also goes around this way. So if we look at one of the lines from I1 on I2, it's now a really big circle going around this way. Well, the magnetic field goes sort of through the page, right? At this point it goes into the page. If we were looking at crossways, if we're looking at from above, it would go up. So an above view of this line, I1, I2, we would see the force, the field generated by I1 wire on I2 is up. And if we look at the field generated from I2 to I1, it goes around this way. It's actually going to be down if we're looking at these from above. Now we can work out the directions of the forces in this case. We point our index finger in the direction of the current, we point our middle finger in the direction of the field, and then our thumb goes in the direction of the force. So we point our index finger up. So for I1, we point our index finger up, we point our middle finger towards us, and then our thumb points in. Or our thumb points to the right. Depends how you're holding your hand, of course. So this is going to the right. So this is the force on current cable 1 due to cable 2. Now if we think about the force on cable 2 due to cable 1, we point our index finger in the direction of I2, which is up. We point our middle finger into the page, and then we find our thumb points to the left. So the force on the other one goes this way. So we find in the case where both currents run in the same direction, the forces are running in opposite directions, right? The two wires are attracting one another. So this is one of two possible orientations of the current. So this is, we'll call this case 1. This is where the currents are in the same direction. Now, let's change color and then think of a second case. Case 2, this is the case where the wire currents run in the opposite direction. So we have wire here, we have wire here. We have the current in one of them going up and the current in the other one going down. It doesn't matter which one is which. One of them has to be one way, the other one has to be the other way. Use our right hand rule to work out the rotational directions or the rotational orientations of the magnetic fields. This one goes around this way. And the other one, if we point our thumb down, it actually goes around the other way in reverse. Now, this one, which we'll call current 1, if its field is extended all the way over to the second wire, the field vector is pointing into the page. So if we look at this one, which is current 2, from above, the magnetic field from current 1 will be into the page, or that direction. If we look at this magnetic field, it will also go in. So this one will go in, this one will go in, so both of them will look like this. And what we're seeing is something very similar to what we saw here. Forces were pointing in, the directions of the fields were opposite. Right? This one was going in this way, this one was going in this way, And now we've swapped the orientation of one of them, and we've ended up with these two forces pointing in the same direction. The problem is the current is now pointing in different directions, right? So last time the current was in the same direction, and then the field was different directions. Now we have current is different direction, field is same direction. So when we use our right hand rule, you point your index finger, we'll do it for current cable 1, index finger up, you point your middle finger into the page, and you'll find that your thumb points to the left. So the force on this one goes outwards. We do the same for the second wire. Our finger points down, our middle finger points into the page, and you'll find that your thumb points out to the right. So this is the second possible orientation, right? Case 2, where you've got one current going up, one current going down. Here the forces point in opposite directions. This was the first possible orientation, where both currents run the same way. Here the forces were also in opposite directions. So the question says, two current carrying wires parallel to each other, is it possible for the forces produced to point in the same direction? No. You cannot have the forces pointing in the same direction. The forces will always point in the opposite directions, regardless of whether the currents run in the same direction or whether the currents run in the opposite direction. So this is the answer to this question.